Hello viewers, in today's class we are going to discuss a very important and interesting problem from continuity of functions, right? So here we are going to solve a very interesting problem in which we have to show that this function f of x, which is a combination of greatest integer function and the fractional part function, is continuous at x is equal to 1, right? So here we have to show that f of x, which is equal to greatest integer of x plus square root of fractional part of x, and this function is continuous at x is equal to 1, right? So here what we will do, we'll first take the definition of continuity of a function. So now viewers, we know that suppose we have a function, say y is equal to f of x in some domain D, right? And suppose we have a point, say x is equal to a, which belongs to the domain of this function f of x, right? Now this function is said to be a continuous function if the limit at x is equal to a it exists, and this limit is equal to the value of the function at x is equal to a, right? So this is the basic definition of the continuity of a function, right? So the limit at x, when x tends to a, must exist, it should be finite, and the limit should be equal to the value of the function at the given point, right? So now further what we will do, we'll find the right hand limit and the left hand limit, right? So this notation is a combined notation for the right hand limit and the left hand limit, right? So the right hand limit is denoted by a limit x tends to a minus f of x. Sorry, here we'll have the positive sign, right? And the left hand limit is denoted by limit x tends to a minus f of x, right? So in order to have this limit to exist, these two limits, that is the right hand limit and the left hand limit, must exist, and they must be finite, and both the limits should be equal, right? So once right hand limit and the left hand limit are equal, then we can claim that limit x tends to a f of x exist, right? And then we'll find f of a, and if both these quantities get equal, then we can claim that the given function is continuous at the given point, right? So here we are given this function, and we have to test the continuity, or we have to show that this function is continuous at x is equal to 1. So here a is given to be equal to 1, right? So now let us start, and let us first take f of x is equal to the greatest integer of x plus square root of here we have the fractional part function, right? And we know that the fractional part function is defined like this, that is x minus greatest integer of x, right? So here we'll write x minus greatest integer of x, okay? So now see, this is the fractional part of x, and we know that the domain of the fractional part of x is the set of all real numbers, and the range of fractional part function is from 0 to 1, right? Okay, so now let us first find the right hand limit. So for right hand limit, what we will do, we'll write limit x tends to 1 plus, right? So this positive sign shows that we are approaching towards x is equal to 1 from the right of x is equal to 1, right? So limit x tends to 1 plus, and here we'll write f of x. Now this is the limit x tends to 1 plus, and for f of x we can write greatest integer of x plus square root of x minus greatest integer of x, right? Okay, So now we'll take x is equal to 1 plus h, right? So we'll here substitute x is equal to 1 plus h, and h is a small quantity and it is a positive quantity, right? So h is greater than 0 but it is less than 1, right? So we'll just take this substitution, that is x is equal to 1 plus h. Why we are taking 1 plus h? Because see, this quantity, that is 1 plus h, it lies towards the right of x is equal to 1, and we are approaching from the right of x is equal to 1, right? Okay, so when x tends to 1, obviously h tends to 0, right? And here we must keep one thing in mind, that this quantity h is a very small quantity, and it lies between 0 and 1, right? So now this right hand limit, it takes the form in terms of h, that is limit h tends to 0. Now here we'll have h tends to 0, and we have greatest integer of x. For x we can now write 1 plus h, and here we have square root of 1 plus h minus greatest integer of 1 plus h, right? So now we have to evaluate this expression, right? So here we cannot directly substitute h is equal to 0, right? So what we will do here, we'll make use of the definition of greatest integer function, right? See, when h lies between 0 and 1, it means h is a positive quantity, right? So h is a positive quantity. So 1 plus h, this quantity, that is 1 plus h, is slightly greater than 1, but it is less than 2, right? So we have 1 plus h lying between 1 and 2. So when 1 plus h lies between 1 and 2, then this implies that the value of greatest integer of 1 plus h is equal to 1, right? Okay, so now here for greatest integer of 1 plus h we can take 1. So we have now limit, here we have h tends to 0, here we can now write 1 plus, and here we have square root of 1 plus h minus 1, right? And now this one and this one get cancelled, and now we are left with the limit h tends to 0. We have 1 plus square root of h, right? And now this square root of h tends to 0 when h tends to 0. So we have 1 plus square root of 0, that is 1 plus 0, that is equal to 1, right? So the right hand limit of this function when x approaches to 1 from the right of x is equal to 1 is 1, right? So now we can here write the right hand limit as equal to 1, right? So now let us find out the left hand limit. So now the left hand limit can be written as limit, here we can write x tends to 1 minus, so here we'll have the negative sign. The negative sign shows that we are now approaching towards x is equal to 1 from the left of x is equal to 1, right? So we are approaching from this side. So we have here f of x. Now we can substitute the value of f of x, which is greatest integer of x, plus square root of x minus greatest integer of x, right? Okay, now here we'll make the substitution, that is x is equal to 1 minus h, right? So whenever we have to calculate the left hand limit, we must take x is equal to 1 minus h, or in general when we take the right hand limit, we must substitute x is equal to a plus h, where a is some number, and here x should be taken as a minus h, right? Okay, so here again h is a positive quantity and it lies between 0 and 1, right? So when x tends to 1, obviously h tends to 0. So now the left hand limit is equal to limit h tends to 0. Now we can transform this limit in terms of h. So we have here 1 minus h for x, and then here we have square root of 1 minus h minus and 1 minus h, right? Okay, so now again we cannot directly substitute the value of h is equal to 0 in this expression, but what we will do, will again make use of the definition of greatest integer function, right? And see, we have already claimed that h is a positive quantity, so 1 minus h, right? 1 minus h is greater than 0, but it is slightly less than 1, right? Because h has some value. So when when we subtract h from 1, we get a number or quantity which is greater than 0, but that is slightly less than 1, right? Okay, so now by the definition of greatest integer function, when 1 minus h lies between 0 and 1, the value of greatest integer of 1 minus h must be equal to 0, right? See, in the case of right hand limit, we had the value of greatest integer of 1 plus h as 1, right? But here the greatest integer of 1 minus h is 0, as 1 minus h lies between 0 and 1. So now this limit, it takes the form, here we'll now write 0, and we have 1 minus h, and here we have 0, right? Okay, so now we can write limit h tends to 0, and here we have square root of 1 minus h, right? So when h is 0 here, we get square root of 1 minus 0, that is square root of 1, which is equal to 1, right? So we see that the left hand limit of this function, when x approaches to 1 from the left of x is equal to 1, the left hand limit is also equal to 1, right? So now we conclude that the right hand limit and the left hand limit both exist and they are finite, right? And both the limits are equal. So now we can claim that the limit x tends to 1 f of x, it exists, right? It exists and it is equal to 1. So now let us calculate the value of f of a, and f of a is our f of 1, right? So f of 1 can be easily calculated from this expression by taking x is equal to 1. So we have a greatest integer of 1 plus, here we have square root of 1 minus greatest integer of 1, right? And we know that greatest integer of 1 is simply 1, because for all integer points we have the same integer point here. So here we have 1, and here we have square root of 1 minus 1. So this is 1 plus square root of 0. So this is 1 plus 0, that is 1, right? So now we conclude that the right hand limit is equal to left hand limit, and that is equal to f of 1, and both all these three quantities are equal to 1. So we can claim that this function is continuous at x is equal to 1, right? So viewers, this is how we can solve these type of problems.